Hello, everyone, and welcome to the mASKerAId, the first mASKerAId where your real identity will not remain hidden. mASKerAId is a software solution that increases the accuracy and reliability of any existing facial recognition software with our custom-made facial reimaging. This presentation will be brought to you by our team, including myself, Derek, CJ, Aruna, Neha, and Ann. As everyone knows, COVID-19 has given all of us countless problems, but more importantly, it has forced a new normal upon us. Part of this new lifestyle we must live is wearing a mask when going out into public. Although this does keep us a little more safe, it also presents us with a whole new problem. As you can see in this crowd of people, everyone now hides their identity behind a mask. Hiding these key facial features makes existing facial recognition software much less accurate and even sometimes not work at all. This presents a huge problem because of how much we rely on facial recognition today, whether it be to prevent crimes, find missing persons, aid in forensic investigations, and even help diagnose diseases. Facial recognition is used in a wide array of industries and markets, so our new normal of wearing masks can negatively affect anyone. So what's the solution? mASKerAId, where we ask AI what these people would look like. For mASKerAId to be as accurate as possible, we must first build and train a model of people with similarities to our unknown entity. This can be done within any organization by first training a custom prediction model to the organization's existing database. For example, if mASKerAId is being used to help prevent crime in a local town, the local police department could use their criminal database to train the most likely prediction model. From there, they could input any image captured where the unknown entity has a mask or other partial face coverings, and mASKerAId will then generate a new image of what that person would look like underneath those hidden facial features. The goal here is to produce an image that is most likely to return a successful result to any existing facial recognition software. Or, even better, if the generated image is a near match to the database that mASKerAId was trained on, the person will then be found. So what makes mASKerAId so important? With facial recognition being a relatively new and growing field, not all solutions out there now are perfect. Many do not have advanced algorithms to generate accurate results with missing facial features. So there needs to be an intermediary step in between image detection and facial recognition that can be used as a plug-and-play solution to help guarantee that a person can be identified. In order to do this, mASKerAId will be available from a web service that allows multiple users within an organization to both train an accurate model and generate better images to input into their existing software. mASKerAId isn't just another facial recognition solution. It's a facial recognition aid, a mASKerAId.
Thank you, Derek. Hello, everyone. This is Neha. Coming to the market research, there are a variety of softwares or applications already present in the market, which is commercially available and is still under practice. The highly rated among them are BioID, Railer, and FaceFree. BioID is one of the popular products which is used for authentication using face. This is used in mobile devices to authenticate the device using the facial recognition rather than a typical password. Face authentication makes the device more secure as it has lower error margins. Next is Railer. It is used as an attendance app for many small and large companies. This makes it easier for an organization to track the presence of an employee in a shift or on a particular working day. Another popular one is FaceFree. It is used in the banking sector to help a customer securely log into a mobile banking. This is used as a replacement to log into mobile banking because face as a password is nearly impossible to hack. Coming to the revenue, BioID generates an annual revenue of close to $15 million. FaceFree generates an approximate revenue of close to $5 million. But again, all of this product has a limitation. None of them are able to reconstruct a face which is partially covered either with face masks, sunglasses, or any other partial face covering elements. Most of the softwares are even more complicated to use, either because of its functionality or because of its complicated GUI. It is even difficult to integrate the software package to other similar environments as well. Few of them are also not able to collaborate with all the organization's database. Typically, these are designed to work with only kind of organization, and it is difficult to bridge the gap to make it compatible to use with other data sources. Let's talk about the target market and value propositions. In this current trend, AI applications or its implementations are widely used. The industry which is in deep integration with AI is travel industry, which has potentially 120% larger users than any other analytical techniques users. So this can be one of our target market to provide them with smarter and better product mASKerAId. In precise, it can be used at the security checks at the airport where the traveler does not need to remove the mask multiple times. Just in case the database does not have the picture of the traveler, then during the departure time, the traveler needs to remove the mask where the picture of the traveler will be taken, and the same picture will be used at the arrival time to reconstruct a face of a traveler. The next popular AI used industry is transport and logistics, which can use mASKerAId to detect the authentication of a person who is taking the lead role of a chain and is handling the logistics. AI's improved performance and its smarter techniques has made it being used widely than any other analytical techniques. In sync with the above statement, mASKerAId is easy to use by multiple users within an organization or any other business firm. mASKerAID has a brand new introduced feature of reimaging a face or a facial image which is partially covered. This can be easily integrated with any other face recognition software available in the market to make it as a face reconstruction software. It can be easily customized as per the user's database for more accurate predictions. Last but not the least, mASKerAID is not confined to only COVID-19. It can be used beyond that to reconstruct a face which is partially covered. Now Aruna will talk about the business model in details. Thank you.
Thanks, Neha. Hi everyone, this is Aruna and I will be discussing the business model of our product. Coming to the first component, our key partners include cloud computing service providers like Amazon Web Services. And we will be building an accurate facial reconstruction app, and the key activities include research and development, marketing of the application, and custom database model training. The most important key resources needed to make our business model work include machine learning algorithms, neural networks, deep learning, web interface, and the team of our developers. Our product reconstructs the face with highest probability on any image with missing features. We'll be able to generate prediction models customizable to any organization's existing database. Due to these value propositions, customers turn to our product. And coming to the customer relationships, it is highly scalable, as in it can able to handle a large increase in users or workload, and easily accessible, and without any personal assistance customers can use it, and it can be customizable to any organization's data. Coming to the channels, our product communicates and reaches its customers via mASKerAId web application, custom API, GitHub, and social media. The potential customers to our product include all companies that rely on facial recognition like security, medical, education, etc. The most important expenses include high cost of the algorithm and its complex architecture development, continuous research and innovation since facial reconstruction is something brand new, and hosting of the web service. Our product will be provided to the users for a subscription fees, either a monthly or yearly. Also, we are going to charge one-time fee to any organization to build a custom prediction model on the current database to provide better results. And machine learning as a service, which provides machine learning tools as part of cloud computing services. Basically, this helps clients benefit from machine learning without establishing an in-house internal machine learning team. Coming to the statistics and expected growth, entire facial recognition market is growing to have $7 billion by 2022. So our product is estimated to reach this entire market at 5% by year 1 and 15% by year 3. Yearly subscription cost may range between $50 to $5,000 depending on the customers. And our product is projected to gross $1 million by year 1 and $5 million by year 3. Yeah, so that's all about the business model of our product and expected growth in the next 3 years. The remaining part will be continued by Anne. Thank you.
Hey, this is Anne here. There's a few things that the mASKerAId team would love to have. We understand that these asks are a bit out of scope. We certainly aren't expecting to receive most of them, but these are the items that would give us the best chance at better success. The first item on our wish list is a grant, most likely from the DoD, as our research and development in facial recognition has lots of benefits to offer them. Secondly, access to a supercomputer would allow for faster API calls on our backend, so this would be great to have as well. Finally, large data sets to train our AI with would be a really good thing for us. Of course, we would also love any and all feedback. Our email and our Instagram are located on the slide, and also feel free to explore our code as it evolves on GitHub, and that GitHub link is also located on the slide. Let me introduce our team. First, we have our team lead, who is Derek. He currently works as a full stack engineer. Our next team member is CJ. He currently works as a big application developer. Our next team member is Aruna. She works as a data analyst. Neha is our next team member, and she works as a software engineer. And finally, there's myself. My name is Anne, and I work as a software engineer as well. And with that, I'll go ahead and pass it on to CJ to talk about tools and technologies.
Thank you, Anne. Hi, this is CJ, Chandan Kumar Patel, and I'll be carrying on the presentation from this point onwards. So let's start with tools and technologies that we are using for this project. For our team meetings and design discussions, we are using WebEx. We host our documents and presentations to be shared among using Google Docs. To implement artificial intelligence algorithms, we use OpenCV with Keras and TensorFlow, and we use Python as the primary programming language to implement these AI algorithms. And till this point, we have successfully been able to implement 3 algorithms, that is LBHP algorithm, agent vector algorithm, and Fisher's algorithm. For RAD, that is Rapid Application Development and Prototyping, we are using tkinter. We develop our front end using Python as the primary language, Flask or Django as the web service element, HTML, CSS3, JavaScript, and React. Our backend consists of primarily Python, and for database, we depend on MongoDB. For artificial intelligence model serialization, we use Pickle, and for code sharing, we will be using GitHub. Okay, now let's talk about the current status of our project. So we have achieved quite a good milestones. We have successfully been able to have a sample image database containing faces. We have also implemented, I mentioned earlier, 3 of the artificial intelligence algorithms. And we have also created a prototype that works perfectly, and I'll be delighted to show you its working, that is able to recognize the faces that are partially covered currently with goggle and cap. Okay, now let's talk about obstacles. So we don't have any obstacle as such, but the main constraint is that getting a ready-made data set to train our algorithms. Because to train our algorithms, we need a data set containing images of various people in various postures and preferably various expressions, and with partial covering of face, and without that so it's difficult to get such thing. So what we are doing is our team members are supplying their images in this required format, and we are using this data set to to train our algorithms. Now let's talk about our potential customers. So by now you would have realized that this is not a general purpose application that anyone can download from App Store and use, but rather this is a security related application, and hence our customers, potential customers, would be a couple of government agencies and some private security firms, those who would be interested in knowing or identifying a face that is behind a mask. Okay, now rather than showing you the rest of the PPTs, let me give you a live demonstration of the artificial intelligence framework that we have developed. So let me run this framework. Okay, let me put it in the center of the screen. Fine. So the name of the application is mASKerAId, as you can see it over here, and it has a couple of fields. First field is that select a test image. So what's a test image? A test image is an image that is partially covered. That means maybe under cap or heavy cap or goggle or with COVID mask or something like that. And we are interested in knowing who the person is behind these hiding attributes. Okay, so let me select one such image by browsing. So this is our project directory, and this is the pictures. So let me say Charles. Okay, I just given the name randomly. So this is the image we want to identify who the person is. And as you can see, nearly 30% of the face of this person or the facial features of this person are hidden. Okay, and we are interested in knowing how this person would look without goggle, or who the person is, to be more precise. Okay, another feature is we would like to get the base directory. So before explaining you what a base directory is, let me select first, and okay, now we go here. So now what a base directory is. Say this person is a criminal and the agency is interested in identifying his face, who the person is behind the goggles. So in that case, the base directory serves as a dataset containing the mugshots with the police department. So what we have done is our artificial algorithms are trained to learn the facial features of this mugshot dataset, and it has learned all this thing, has acquired the knowledge, and now when we process the data set, process this image, it will learn its features and try to compare the facial features, and if these features are matching with its acquired knowledge beyond a certain point of doubt called the threshold, then it will say okay, match is found. All right, and this interface also allows us to select various algorithms. Right now we have 3 algorithms. In near future we plan to add 2 more and implement them. But let's start with the processing. So when I process, and I keep my fingers crossed and hope to see the person who is there behind. Yes, he is identified. Now you can see that this person without goggles should look like this, and there is a match. Okay, so this is what we have been able to do till this point. Our next step will be to implement these algorithms with the masked faces, that is with COVID mask, and thereafter we will implement this artificial intelligence framework into a web service framework so that it can be accessed using a distributed computing framework over any platform, across any platform, over any of the application, maybe if it is in Java, maybe it is in PHP or whatever, whatnot. Okay, but it should be able to exchange the data with that, and that is, I think, the real crux of distributed computing. And with this, I would like to end my presentation. Thank you very much.